This paper is titled Unimodal Model for Emotion Detection in Immersive Virtual Learning Environments Using Spatial Analysis of Hands and Head. Emotion detection in virtual reality primarily uses multiple devices to record physiological signals, as well as computer vision for facial recognition or postural analysis. This implies technical and practical limitations for a massive implementation, as well as interfering with the user's normal movements and behavior. There would exist a feeling of being watched, and the sensors are generally not comfortable to wear. This paper calls these conditions the multimodality problem. For emotion representation, the use of participants who interpret stereotypical characteristics of an emotion, regardless of their emotional state, is a common approach. A particular group of emotions is usually requested, assigning the recorded data to the instruction and not to the genuine emotion. This paper calls these conditions the a priori labeling problem. Emotions are coordinated systematic responses of the human body towards different events and stimuli. These can trigger actions that can be expressed through movements, gestures, and changes in posture. The model proposed depends only on head and hand behavior and an emotional self-assessment. Both come directly from the user. To collect the data, experiments were conducted using the immersive virtual learning environment Pinta tu Raya Así. This virtual environment serves as interactive didactic material to train primary school-aged children in the prevention of child sexual abuse. No attempt was made to induce a specific emotion in any of the scenes, so everything is a spontaneous and natural reaction to the environment. The experiment followed a straightforward protocol. It starts by assembling a group of participants and give it an introductory speech. Then comes a phase of pre-training, followed by a virtual reality interaction. Here, a demographic questionnaire is responded, device's position and orientation is recorded, and emotional self-assessment per scene is conducted to obtain balance and arousal values. Finally, an exit questionnaire is responded and qualitative feedback is given. Primary and spatial features were extracted, generating mean and median vectors with 124 features. After principal component analysis, a vector with 3 features for the mean approach and a vector with 25 features for the median approach were generated. Smooth was implemented to augment and balance the sample count. Random forest regression techniques were then used to predict balance and arousal values, splitting the data in 80% for training and 20% for testing. Here, the best hyperparameters and their regression results for each model are shown. It's important to notice the difference between the results of the 20% test sample split and a 10% random samples with paired data. The model achieved accuracies of 76% and 70% for balance using the median and mean respectively. Accuracies of 87 and 83% for arousal were achieved using the median and mean respectively. The median-based approach improves performance, although it involves higher feature dimensionality. This model enables the non-invasive inference of a user's emotional state in virtual reality environments without cables or extra sensors, effectively addressing the multimodality and the a priori labeling problems. These results provide a foundation for integrating effective tutors in immersive virtual learning environments, with potential applications in education and training involving large groups.